Welcome to another unit in business mathematics. This time I'm going to talk about matrix multiplication. So in the last unit we talked about how we can add up two matrices or subtract one matrix from another. We still have to talk about how I can multiply two matrices with each other. And that's what we're going to do here. As compared to the matrix addition and subtraction, where we had the requirement that both matrices need to be of the same size, here, when we want to multiply two matrices, we can first differentiate which type of multiplication we are talking about, and depending on this type, we then have comparable requirements as well. If we only want to multiply matrix with a given number, like in this case here with a number r, we can simply multiply all the elements of the matrix with this specific number. So that's relatively easy and straightforward, as we can also see from this example. So here in this case we have 3 times then the matrix, so this means we can multiply each of the 4 elements with 3 and get our results. So in this case, we not yet have any specific requirements. But as soon as we multiply two matrices, or even if we multiply a vector and a matrix, because in this case vectors are regarded like matrices, we have particular requirements. The first real requirement for this to even be possible is that I need to consider columns and rows of the two matrices. In particular, the number of columns in the first matrix, so in the matrix on the left, need to be exactly the same as the number of rows in the matrix on the right. Why? We're going to see next slide when we do an example and when we really calculate this, but this is actually a really important requirement, else we cannot multiply the two matrices. And then we also know what the result will look like, because the result will have the same number as rows as the left matrix and the same number of columns as the right matrix. So that's exactly the opposite from the requirement. And well, considering this requirement might also or already make sense that, well, there is a difference whether I calculate A times B or B times A with matrices. Because could be the situation that one of the two is actually possible, whereas the other one is not. Could be that if I multiply A times B, I will get only a 1 times 1 matrix, but if I multiply B times A, I will get a 3 times 3 matrix. So all these are actually possible outcomes, so that's a really important aspect to consider with matrices. Multiplication no longer works as it did with normal numbers. So A times B is in most cases not equal to B times A. So that's actually the first requirement I just mentioned. The product A times B can only be calculated if the number of columns in A, so on the left, equals the number of rows in B. The result, that's actually the numbers of rows in A times the number of columns in B. So if we consider this example, here we have a 3 times 2 matrix and a 2 times 3 matrix. So we see the number of columns in the first is 2. The number of rows in the second is 2. So those two fit. So I can multiply these two matrices. And then the result is 3 times 3, because I have 3 rows in the first one, 3 columns in the second one. And well, that's actually the formula for this. However, it makes more sense if we actually understand what is happening here. And this could best be done with an example. So if we consider this example here, what we actually do is we take for the first entry here, so that's the entry at position 1, 1. So we take the first row and the first column. Then multiply the first entry with the first entry here. So 6 times 2 plus second entry here, second entry here, plus 4 times 1. So I have 12 plus 4. That's this part here, giving me 16. If I'm here, I'm at the first row, second column. So I take the first row from the first matrix, second column from the second matrix. And I go 6 times 7 plus 4 times 5. That's this here. If I'm down here, that's the second row, third column. So second row, third column. So I take second row, this one here, and third column, this one here. And go 1 times 3 plus minus 7 times 8, this part here. And then, when I've done with all of this, I simply just calculate what I've written down here and get this result. Well, it's easily understood what is happening here, but we can structure this even a bit more. For this, we're going to use the so-called forks schematic. Here, we're writing our left-hand matrix, so the first one on the left. And on the upper right, we write down our right-hand matrix. So for example, the B. And then we see where the rows here and the columns here intersect. So at this point, this row, this column intersect. So at this point, I'm simply combining them. First one here, first one here. Second one here, second one here. Write this here. Then I'm down here. First one here, first one here. Plus, second one here, second one here. And then add this up in the end. So this just structures it a little bit more than as to compare what we did in the slide before. And well, that's already all there is to matrix multiplication. We talked about the requirements. We talked about that A times B is not necessarily, or rather almost never, equal to B times A, and how to actually do the multiplication, either if we multiply a matrix with a number or two matrices with each other. If you want to multiply a matrix with a vector, well, a vector is either a 1 times n matrix or an n times 1 matrix. If you just keep this in mind, you can use this same schematic, the same rules as used before. Well, that's then everything I wanted to talk about. So thanks for listening and see you next time. Goodbye.